Hi everyone, it's Lucy Kim from the Peer Tutoring Club. In today's video, we're going to continue learning about measurement. We are working on definition of speed, conversion of area, conversion of length, and unit of measurement. In today's video, we're going to work on unit converter, errors in measurement, and percentage error. Let's look through unit converter. You can go to Google and search unit converter. Then the Google will show this material. You can use this material to convert any units. So this is really useful, so I hope you to use this anytime when you're struggling with units. Now we can move on to errors in measurement. When you found any errors in measurement, it's not about whether you measure it right or wrong. This is about accuracy. So measuring instruments are not exact. Now let's look at the degree of accuracy. Accuracy depends on the instrument you're measuring with. But as general rule, the degree of accuracy is half a unit each side of the unit of measure. Let's look at an example. When your instrument measures in ones, then any value between 6.5 and 7.5 is measured as 7. In other case, when your instrument measures in twos, then any value between 7 and 9 is measured as 8. Notice that the arrow points to the same spot, but the measure values are different. We can show the arrow using the plus or minus sign. When the value could be between 6.5 and 7.5, the arrow is plus minus 0.5. When the value could be between 7 and 9, the arrow is plus minus 1. For example, a fence is measured as 12.5 meters long, accurate to 0.1 of a meter. Accurate to 0.1 meter means it could be up to 0.05 meter. Either way, length could be 12.5 plus minus 0.05 meter. So it could really be anywhere between 12.45 meter and 12.55 meter long. Now let's look at the absolute, relative, and percentage error. The absolute error is the difference between the actual and measured value. But when measuring, we don't know the actual value, so we use the maximum possible error. In the example above, the absolute error is 0.05 meter. Then what happened to the plus minus? Well, we just want the size of the difference. The relative error is the absolute error divided by the actual measurement. We don't know the actual measurement, so the best we can do is use the measured value, which is relative error equal absolute error divided by the actual measurement. The percentage error is the relative error shown as the percentage. For example, continuing, when the fence length is 12.5 plus minus 0.05 meter. So in this case, absolute error is 0.05 meter and relative error is 0.05 meter divided by 12.5 meter, which is 0.004 meter. And percentage error should be 0.4%. Let's look at another example. The thermometer measures to the nearest 2 degrees. The temperature was measured as 38 degrees. The example could be up to 1 degree either side of 38 degrees. So the temperature should be 38 plus minus 1 degree. So the absolute error here is 1 degree and relative error is 1 degree divided by 38 degree, which is 0.0263 and more. And the percentage error should be 2.63 and more percent. Let's look through one more example. You measure the plant to be 80 centimeter high to the nearest centimeter. This means you could be up to 0.5 centimeter wrong. The plant could be between 79.5 and 80.5 centimeter high. So the height should be 80 plus minus 0.5 centimeter. So the absolute error should be 0.5 centimeter and relative error is 0.5 centimeter divided by 80 centimeter, which is 0.0065 centimeter. And the percentage error should be 0.625%. Now let's look at the area. When working out areas, you need to think about both the width and length. They could possibly both be the smallest measure or both the largest. For example, when we say Alex measured the field to the nearest meter and got a width of 6 meter and a length of 8 meter, Measuring to the nearest meter means the true value could be up to half a meter smaller or larger. So the width could be from 5.5 meter to 6.5 meter. So we can say that width is bigger or same as 5.5, but smaller than 6.5. The length could be from 7.5 meter to 8.5 meter. So the length should be bigger or same as 7.5, but smaller than 8.5 meter. So the area is width times length. So the smallest possible area is 5.5 meter times 7.5 meter, which is 41.25 meter square. The measured area is 6 meter times 8 meter, so it should be 48 meter square. And the largest possible area is 6.5 meter times 8.5 meter, which is 55.25 meter square. So the area should be bigger or same as 41.25, but smaller than 55.25. Then, which is the absolute error? From 41.25 to 48, there should be 6.75 difference. And from 48 to 55.25, there should be 7.25 meter of difference. So the answer should be the biggest one here. So absolute value is 7.25 meter square, and relative error is 7.25 meter square divided by 48 meter square. So it should be 0.151 and more. So the percentage error should be 15.1%, which is not very accurate, is it? Then, now let's move on to volume. Volume has 3 measurements: width, length, and height. Each measurement could possibly be the smallest possible measure or the largest. For example, Alex measured the box to the nearest 2 cm and got 24 cm times 24 cm times 20 cm. Measuring to the nearest 2 cm means the true value could be up to 1 cm smaller or larger. The 3 measurements are 24 plus minus 1 cm, 24 plus minus 1 cm, and 20 plus minus 1 cm. So the volume is width times length times height. So the smallest possible volume is 23 centimeters times 23 centimeters times 19 centimeters, which should be 10,051 centimeter cube. The measured volume is 24 centimeter times 24 centimeter times 20 centimeter, which should be 11,520 centimeter cube. The largest possible volume is 25 centimeter times 25 centimeter times 21 centimeter, which should be 13,175 centimeter cube. And so we get volume is bigger or same as 10,051, but smaller than 13,125. So the absolute error should be from 10,051 to 11,520, which is 1,469, or from 11,520 to 13,125, which should be 1,605. So we need to pick the biggest one. So the absolute error should be 1,605 centimeter cube. Then the relative error should be 1,605 centimeter cube divided by 11,520 centimeter cube, which is 0.139 and more. So the percentage error should be 13.9%. If you're struggling with percentage error, then now let's look deeply into percentage error. So the way to calculate the percentage error is you need to calculate the error firstly, and then you need to divide the error by the exact value, and then you need to multiply by 100 and add a percent sign to convert that to a percentage. So it was all about today's video. Thank you for watching and see you next time. Bye!